Algebra 1 Common Core, the June 2016 Regents exam, picking up on number 28. Amy solved the equation 2x squared plus 5x minus 42 equals 0. She stated that the solutions to the equation were 7 over 2 and negative 6. Do you agree with Amy's solutions? Explain why or why not. So the solutions to a quadratic like this, there's a couple of things we could do. We could use quadratic formula. We could try completing the square. And those will always work. Completing the square could be a little tricky when there's a number in front of x squared. That's not a GCF, but it's doable. Quadratic formula will always work, but really the value of the quadratic formula is when you have irrational or even imaginary solutions. But here we see that 7 over 2 and negative 6, those are rational. They're just regular numbers, which means that if Amy's correct here, that means we can do this with factoring. So let me show you this question through factoring, and let's see if we get these solutions. And if not, then Amy's wrong. But let's see. So 2x squared plus 5x minus 42. With all factoring methods, the first thing we look for is a GCF. Is there a greatest common factor in here? No. So then we see it's a trinomial, but we can't do basic trinomial factoring because of the presence of the 2 in front of the x squared. So we have to do what I call AC trinomial factoring, or AC factor by grouping. And the way that starts is writing a note off to the side of what AC is, and that's your first times last. So 2 times negative 42, that is negative 84. And you can write x squared too, negative 84 x squared, if we include the 2x squared there. And so what we need to do is in order to do grouping, which is what we want to do, grouping requires there to be an even amount of terms. Right now we have 1, 2, 3. I need to figure out a way to expand this middle term. So I'm going to keep the 2x squared and I'm going to keep the negative 42. But I'm going to get 2 new terms. And so I'm going to expand this trinomial into 4 terms, into a quad. And I can't just put anything here. They have to specifically be terms that multiply to that AC note that we wrote and add to the original B term we have. And so you kind of say, all right, what multiplies to negative 84 and adds to 5? And it might take a little bit of trial and error. There is a nice calculator shortcut here that if you, in your y equals folder, well, after you turn your calculator on, if you type in the number divided by x, the numbers you want the multiples of or the factors of, so negative 84 divided by x. So really anything, if I want to know the numbers that multiply negative 84, or any number, if I want to know the numbers that multiply to 150, whatever, that number divided by x. In this case, it's negative 84. And take a look at the table. So don't forget the divided by x piece. When you pull up the table, it pulls up all the things that multiply to negative 84. And so then you just kind of got to look at this table and say, all right, which of them add to what I'm looking for? And in this case, we're looking for numbers that add to 5. And here you see the top pair right here. Negative 7 and positive 12, they add to 5. So those are the numbers I'm looking for. It's negative 7 and positive 12. Sorry about that. Negative 7, positive 12. And so that's what I'm going to put here. I'm going to erase these boxes, actually. I just wanted to show you that 2 things were going to go there. So a negative 7x and a positive 12x. Now, does it matter if I were to put maybe the positive 12x first and the negative 7x? No, it really doesn't matter. It's going to work out, either way. And so then now we have 4 terms. And so now we're going to do that factoring by grouping. The way that works is we cut it in half. Sorry, it looks like my pen is freezing up for a second. There we go. All right, so we're going to cut it in half and GCF the pairs. So what is the greatest common factor of 2x squared minus 7x? 2 and 7 have nothing in common, but they both do have an x. And when I take that out, I get a 2x minus 7. And same thing with this, 12x minus 42. What do they have in common? Well, they actually, 12 and 42 have a 6 in common, so I could take out a 6. And when I take 6 away from 12x, I get 2x. When I take 6 away from negative 42, and when I say away, I mean divide. Negative 42 divided by 6 it does come out to be -7. And notice that this matches. That's not just a coincidence for this problem. That happens every time when you're doing AC factoring. Then you pair things up. I take the GCFs and group them together. So x plus 6, and I write that common matching pair that I had. But I only write it once. And this whole thing is still set equal to 0. Keep that the whole time. It's an equation all the way through. Now we're done factoring. Now we just need to solve it. And the way you solve these is a little t-chart, set each factor equal to 0. So 2x minus 7 equal to 0. Minus 6, we get x equals -6. Here we're going to add 7 to get 2x equals 7, and then divide 2. So x equals 7 over 2. And so was Amy right? -6 and 7 over 2? Yes, she was. So do you agree with Amy? You just say yes. Those are the, solutions. I'm surprised it says explain here and not justify, because I think we justify it by just showing the work. But explain means why you want to, in words, what you would write here. So, I think this is a bad problem to explain. I think it should just say justify. But, I guess you could just say something like, yes, Amy is correct. The equation has those solutions. You can say from factoring if you want to add a little piece there, but it's like I said, it's kind of a silly equation for you to have to explain, because the math, I think, does the justification enough. All right, so that one question took like 7 minutes. All right, let's move on to another question. That's probably going to take another 7 minutes. Sue and Kathy were doing their algebra homework. They were asked to write the equation of the line that passes through the points -3, 4, and 6, 1. Sue wrote this, Kathy wrote that. Justify why both students are correct. So they're telling you both students are correct. You need to explain why. So basically, let's get the equation. How do we get this? Well, we need to use two formulas. First of all, when you're given 2 points like that, the first thing you should always think of is the slope formula. This formula comes up several times on this exam. Average rate of change is slope formula. And then you also want to think about the point slope formula that gets you an equation. So y minus y1 equals m parentheses x minus x1. These are two must memorize formulas for the test here. So first I'll go with the slope here. So the slope is 1 minus 4, right? Subtract the y values over subtract the x. 6 minus -3. 1 minus 4 is -3. 6 minus -3 is 9, right? Minus a negative. This can simplify down to -1/3. And so that's our m. And then for the point slope formula, you could really pick either point. Let's go with the 6, 1. Actually, no, let's go with this other one because it's got one of each sign, so I can show you how that would work. So y minus y1 is going to be y minus the y value, 4, equals the slope we found, parentheses, x minus the x value, but it's minus a negative, so it ends up being +3, because that whole minus negative, we saw that here too. And so that is Sue's answer. Y minus 4 is -1/3, so she is in a point slope form. Kathy's answer right here is in a regular y equals mx plus b form. Well, we could show that that's also correct by distributing this in. So y minus 4 equals -1/3 x, -1/3 times x, -1/3 x, and -1/3 times +3 is -1. You could use your calculator, but it's times -1 and dividing by 3. Times this, divide this. And lastly, get y alone. So add this 4 over, add 4. We end up with y equals -1/3 x plus 3, which is Kathy's. And justify just means show your work. So we did that. So we're done. So that one wasn't as long. 30. During a recent snowstorm in Red Hook, New York, Jamie noted that there were 4 inches of snow on the ground at 3 p.m. and then 6 inches of snow at 7 p.m. If she were to graph these data, what does the slope of the line connecting the 2 points represent in the context of the problem? So if she were to graph this, like I said, if we were just doing a little rough sketch here, 4, or, time would be on the bottom. So that's, 3 o'clock, here's 7 o'clock, there's 4 inches, 6 inches. So that, at 3 o'clock, there's 4 inches, and at 7 o'clock, there's 6 inches. If we do this little slope here, what does the slope represent? Well, what does slope always represent? Rate of change. But in the context of this problem, the slope would represent the snowfall rate, right? The rate of accumulation, if you want. It's how much snow is falling down, how quickly it's building up. In a span of 4 hours, it went up 2 inches. So I guess, if we were to actually do the slope here, it'd come out to be, like half an inch per hour, I believe, if we were to look at that, because that'd be 2 over 4 is a half an inch per hour. I don't even think they're really asking for what is the rate. They just want to know what would it represent. It represents the snowfall rate. All right, we're at about 12 minutes, so I'll probably stop there. Yeah, I think I'll save 31 for the next video. All right, see ya.